Hey everyone, Kyo here. Now, I don't know if I have promised the winner, Xenonetics, if I'll do the most recent Sudoku of his or not. I don't remember. In case I have, because I couldn't find it in Discord or in Steam, I will attempt the newest one. So here's the Logic Masters Germany of Xenonetics, and as you can see, this was the GANXLE that is published 21st of July. Now, the latest Sudoku is another mathematical phenomenon. Oh, there might be a mathematical phenomenon somewhere here, but probably I did promise to do the latest one, which at the time of recording this, it's this one. Oh boy, it's 4 stars. Oh boy. Oh yeah, so that's the original one. As you can see, it's not even dark purple, so I've never clicked it. I've only been on Xenonetics' site. Oh boy, this looks hard. Let's see how far I can go. I mean, I'll attempt it. Again, I probably promised to do the most recent. I don't know if I have, but if not, Xenonetics, here is my attempt at solving this. Where's Sudoku pad here? I don't even know the rules. So, another mathematical phenomenon. So, by Xenonetics, normal stock rules apply. Yay. Maybe I should read it on the other one here so that we can see the grid. Outside clues are sandwich clues, indicating the sum of the cells between the lowest and highest values. Okay, values, not digits. Hopefully this is not a value digit kind of puzzle. Usually 1 and 9. Seen in their row or column. So what does that mean? If, let's say this column, if we have a, let's say a 1 and a 9, and this is a 5, then this must be also a 5. And again, this does not clash, as you can see. This one clashes because this is not part of the Sudoku. Sven's Sudoku pad is very powerful. It recognizes this is just the outer boundary, basically sandwich clues. So this is possible. Seen in the row or column. Okay, row 0 and column 0, this one. Applies this to each of row 0 and column 0's in column 0 individually. So this one is the sandwich clue of this, and it's the sandwich clue of this, if I understand it correctly. Okay, I need to see if I'm recording because I forgot if I clicked the record button. Apart from value 0, every sandwich clue is unique. Oh, okay, that's good to know. So if this was a 5, this cannot be a 5, or this cannot be a 5 because every clue aside from 0. So if this was a 0, this could be a 0, this could be a 0. That's allowed, but all of them, others are unique. Cells across white dots contain consecutive digits, so that's the white crop key. If this is a 4, this must be a 5 or a 3. Cells across black dots contain one value double, so basically 1 to 2 ratio. Is there a good example there? So I don't know. Let's say if this was a 4, this has to be an 8. It's basically the lower digit times 2 is the bigger digit, or the bigger digit divided by 2 is the lower digit. If multiple instances of 0 are seen by row 0, column 0's clue, which is lowest is to be determined by the solver. We have a small GANXLE here. Nice. So if we have multiple zeros and a big one, let's say a big number, I don't know, I'll just say 9, we have to determine which one it is. That's it. That's all the rules. Oh boy. Cool. Yeah, let's... do I reset the timer? Sure. I'm not going for time at all. I never go for time. Good. So let's start this. Where do we... So, strange thing is the grid itself has almost nothing. It's all about the sandwich clues. I mean, this is peculiar, right? Oh, you know what? Yeah, this is not basic Sudoku rules. Those can be more than 9. They can be 10, 11, and so on. Oh, let's establish some ground rules of sandwich then. So, the basic, if we have a 1 and a 9, this is a 0. Ooh, now the big question is this valid? Is 0 2 times bigger than 0, or is it equal? Because technically 0 times 0 is 0. Of course, 0 divided by 0 makes the world blow up, but maybe I have to figure that one out, but let's just go like that. So this is valid on 9. Now, if we have 1 apart, oh, interesting, a sandwich clue can never be a 1. Because between 1 and 9, you cannot have 2 1s, because that breaks, yeah, see, that breaks Sudoku. So it's between 2 and 8 if it's 1 apart. If it's 2 apart, the lowest is, so this was between 2 and 8. The lowest is a 2, 3. That's the lowest, so 5. And the highest would be 15. That brings me nowhere. But now, you know what? Okay, what if it's the maximum? Or it doesn't matter if it's 1 9. If it's the maximum, we all know it's all the digits from 1 to 9. If they all sum to 45. Now, if we remove the 9 and 1, because they are the sandwich, not the toppings, I guess, the maximum is 35. That's basically 2, 3, 4, 5, 6, 7, and 8, and the sum is 35. So the highest clue, oh, not this one, because, oh wow, this could be bigger. Yeah, so in these, the highest is 35. How do I notate that? I guess, so yeah, this is not pencil mark. If I write it here, this is actually 35. What if it's 31? Okay, this is a 31, right? For the purpose of yellow. Sorry. Great. Okay. All right, that's a basic rule of sandwich clues. So 35 is the maximum, 2 is the minimum. So there can never be a 1. Let's actually check this one, just because this is the most consecutive one. So if this was a 0, no, okay, let's forget zeros, because 0 is wrong. This can never be 0 anyway, because if all of them are 0, even write them like that, if those are all 0, this is the sum of the lowest and highest. So if this is 0, either all have to be 0. Okay, so I don't know if you can still have 0 on black dots, but I know that these do not have 0. Fine. So let's start with the lowest. Well, because this will be the sum. Probably this is the highest digit. Let's see if it's a 1. No, we okay. I established we cannot have a 1 in a sandwich. Can we have a 1 on the other side? 1, 2, 4, and I could have said 2 again, but it said they're unique. So 8, 16, 32. Oops. Oh well. No, that's nonsense. So it has to go from the bottom. So, and we saw it cannot be 1, 2, 4, because 1 can never be here. So let's start and see. So if this is a 2, 4, 8, 16, 32, I mean 64. Oops. That kind of works. Again, the other way around, having 2, 4, 6, 8. Well, you cannot have 64 here, so the other way around. So this is, I think, the lowest that can be. Because this is already 32, not 35, 32, and the highest was 35. So I don't think this can be high. I think that's it, because if this is 3, 6, 12, 24, yeah, so this is already 36. Oh, sorry, not even 36. This is 48. And we cannot get 48, and this is what, 96? So that is the sequence. 2, so that is true. Wow. Because 1 doesn't work and 3 is too big. So 2, 4, 6, 4, 8, 16, 32, and 64. Well, we have a digit here. This is an 8. Wow, I got a digit, and we are 7 minutes in. This is a 3 or a 5. Cool. What about this? I mean, this... Okay, this cannot be 2. So, because they're unique, this cannot be 1. I mean, I still... I mean, can this be 0, 0, 0, 0? If this is the highest digit, which, let's say 35, I don't know. basically having 9 and 1 here. Can these all sum to 64? On average, they have to be 21 on average makes 63, so I guess 21, 20, well, can we have 3 digits? I mean, technically we can have a 62. I mean, oh, we have 32. There's too many possibilities. Can I figure out what these are? If 2 was the lowest digit, what do we have? 32, 48, 56, 60, 60. No, this doesn't count. Oh no, wait. No, sorry. These don't count if those were the highest. So we have 24, 28. It's not 64, so this is not the lowest digit. So let me write this somewhere down. So this is 24. Just ignore these notations in this box. It's just so these are 24. If this was a 0, this would be 26, which is still not enough. So this, if this was the lowest digit, we would need 40. Oops, 40. Okay, this cannot be 40. Like we cannot have 40 because this is the 0, and 4 the zeros. No, is it 40? No, it's not. No, it's not 40. It should be 38 actually, but still, it's too much, right? Because we have now we have the 2, which is 20. Yeah, so my math, come on, 20, 30. You know what? Forget that. If we take the 2, we have 20. We have 30. And we need 30. Okay, we need 34 more if we take the 2 with us. So if this was the 0, this needs to be 34. Aha. It cannot be 30. The same reason it cannot be a 1, it cannot be 34, because if we have 1 and 9, and we have all the other digits, which are in total, all the digits are 35. We need 34. We need to take 1 out, so basically have another 1. Basically, all these are equal to 34, which these is 44, and we need a 1 to be, but we cannot have 2 1s. Okay, so it's not here, so this is not 34. So 0 cannot, or 0, like I mean, it must be 0, because 2 is the lowest number. We cannot have a 1, so 0 cannot be here. Can this be the 0? Because then we have 2 digits that sum to 34. And this also has to be 0. Oh, this cannot be 0 because, oh, because of this. Because even if, so even if these are correct somehow, no, because then this has to be a 1 and we cannot, okay, this is broken anyway, but this has to be also 0 if we allow 0 to be double 0, but we cannot have 0 in Sudoku. Okay, so the 0 is here. Let me remove this. Oh, this is a 1. We got a second digit. And a pencil mark. So now these 3 have to sum to 34. So we have 34. Ooh, I need to do math now. I don't want to open an external thing, but here's the thing. These 3 have to be equal to 34. I need more space. I'll use this row real quick. Sorry. No, yellow. No, don't have yellow with yellow, I guess green. So we have 34. Nope. Equals 3. So if we go with X, Twitter's called X now. A? Man, or Z, Gen Z, whatever. Let's say A. So let's say one of these is A. Let's say A is because one is double the other. Let's say this is A. How do I write it? This is A. This is 2A. 2A I don't have minus. 2A minus 1 or 2A plus 1. Now it could also be the other way around. If this is a, this is 2a, and this is basically a plus 1 or a plus 1 or a minus 1. But let's say we have one of the black dots is a. Okay, let's do some math. So let's say we have, let's say if a, so what do I have here? We have a plus, okay, you know what? I'll say times. This is a other plus, so this is a plus. That's not a times. We have a plus 2a plus, so we have a plus 2a plus. Okay, this has two possibilities. The one is 2a plus 1, and the one other reason is 2, so 2a, and the other one is 2a plus 1 and 2a minus 1. How do I... Let's say this is the plus 1, this is the minus 1. The other possibility is a plus 2a plus a plus 1 and minus 1. Don't disregard this. So if we do math, and we have 34 on the other side, so basically, I mean, I want to delete the red, so let's start with the bottom. So we have 30, oops. So we have 34 equals a plus 2a, a plus 2 times a plus 1 minus 1. So we have a plus 2a plus a. So we have 4a. Let's say we have here 4a. Oh, I mean, you know what? No, screw that. Yeah, we have either a plus 1 or a minus 1. We take it to the other side, so we have either 33. Oh, okay, we have either 33 or 35 as a result. 33 or 35. And 33 or 35 is equal 4a. If we divide by 4, neither 33 divided by 4 nor 35 divided by 4 is an integer. So we got 8.75 or 8.25. Which does not, okay, so that's not correct whatsoever. So it must be 2a. So this is a and this is 2a. And now we have the 2a plus 1 or 2a minus 1. So we have 34, we have 2, 4, we have 5a. So 34 equals 5a plus minus 1. We don't know which one it is, but we do, because if it's 5a minus, no, sorry, other way. If it's 5a plus 1, we remove 1 from both sides. So we have 34, if it's plus 1, so we have 34 minus 1 equals, so 33 equals, oh, I cannot write 33, but 33 equals 5a. And that doesn't work because 33 divided by 5 is 6.6 or whatever. So that doesn't work. So it has to be in this equation, 34. If we remove 1 doesn't matter, but if we add 1 to 34, basically if it's a plus 2a plus 2a minus 1, and we add 1 on both sides, the minus 1 is gone, so we have 35 equals 5a. And why did I, a 35 equals 5a, which means a, well, a equals 7. Wow. So the smaller one we have, we have 7, we have 14, and this has to be, this doesn't work. No, it was a plus 2a plus 2a minus 1. So the bigger one, okay, sorry. So the smaller one is 7, the bigger one is 14, and we had to, it was minus 1 because we had to add plus 1 on both sides to work. So minus 1. So this is 13. Right? Because if you check this now, this must be 34, right? 13 and 14 is 27 plus 7, 30. Yes, okay, we got this. Math. Wow. This now is a 7. 7. This has to be a 9, because this is a 0 now. Let me remove this. Great. Now what? Because... Oh, so maybe go with this now. Because I figured out if this is a 1 and... Oh, well, this is already a 1. Just ignore the 1. That's it. If this is a 1 and 9, everything here is 35, and we have 32. So to have a 3 less, we have to have the 3 outside. Can we have... No, we cannot have... Oh, so let's do this a 9 and this a 1 so that it doesn't clash. Now, this is 35. Now, if we remove the 1 and put it here, for example, this could be 3, because now this whole sandwich is the numbers from, well, from 1 to 9, except 1, 3, and 9, which is 32. Either we have a 1, 9 here, and this is the 3, or we have 1, 9 here, and this is the 3. Now, this notation is not really correct, because if you see here, oh, we have 3 digits and 4 boxes, right? Which is not good, because let's say, because of this 9, let's say this is a 1, this is a 9, and then these two have to be 3, which is wrong. No, this notation is not really correct, because I should note it is 1919, because one of these is the normal other digit between 2 and 8. Because let's say if this was the this was the border, 9 and 1, this can be anything. And the same thing if this is from 1 to 9, from 1 to 9, this can be everything. Now, I'm just thinking. So this cannot be a 1 because of this one here. This also cannot be a 9 because of this 9 here. So either it is a 3, 1, 9 in this order, 3, 1, 9, or the other way was this has to be a 9, this has to be a 1, and this has to be a 3. Both still work. Let's see something else, because now I need to go back to this. Because if this is a 9, this... Wait, if this is a 9, this has to be a 35, which makes it the largest. Nine, 1. So let me just go away from the thought that all of these are 0. Oh, they cannot. No, they cannot be. That's it. Okay. So in the beginning I thought, okay, this could technically be possible because 0 is double 0, which is still 0, which I don't know. But for this to be a 0, what does that mean? We need to have the 1 here, because now it's 0. Because if the 1 is not, then if the 1 is here, we already have a sum. So these two are equal to this one, so it's not 0. So for this to be 0, these both have to be 1, which breaks. Ooh, I did not want to delete that one, but okay, it's not 0. That's good. None of these is a 1 because we established 1 cannot be a clue, a sandwich clue. 2, we have a 2 already. 3. Well, 3, 6, 12, 24. Or the other way around. Okay, that's valid. 4, okay, we cannot have 4. 5, 10, 20. Oh, 40. We cannot have 40 because again, maximum is 35. Oh, my towel fell. Sorry. Okay, so we cannot have 5. So yeah, it must be 3. Ah, I see. Okay, so it's either, oh, how do I note this down? It's either a 3, 3, 6, 12, 24. So this is either a 3 or a 24. I'll do it like that. And this one is either a 6 or a 12. Oh, no, this can never be a 3. Because for this to be a 3, it's basically like that, but now it's the reverse because the 3 is not outside, it's in the inside. This has to be a 1 for this to be a 3. So now the 3 is sandwiched between 1 and 9, so this is correct, but we already have a 1. And I think I already proven that if this is a 1, the minimum here is 2, 3, which is 5, which is again not 3. So this is not a 3. Okay, I think that establishes this is 24, 12, 6, and 3. Where's the 1? Oh, this now can never be a 1, because if this is a 1 with a 9, this is 35, and it's not, so this is not a 1. Oh, and because this is never neither a 1 nor a 9, now we know these are the boundaries, because these cannot be the boundaries anymore. So these are the boundaries, which means these are the boundaries. So which means this is now the 3, which means this is the, oh, 3 in the corner. This is a 9, and this is a 1. Because now this is 32, with this one is 35, and with these two it's 45. And again, every row, column, and box is 45. So, oh, great, great. That's now 35. 35. And this is the maximum possible digit ever here. Something more interesting, this one, this is always the highest, so it always starts counting from here. How much do we have here? Because this is not the lowest, because this is not enough. So if we take all, if this was the, and we know it cannot be 1 or 2, if this was the end, how much do we have here? 34, 36, 42, 45. We need 19. We need 19 more. So this is never a 0. How do I note this down? We need 19 more. Oh, and if let's say the last one is 0, so I have 3. Okay, this one has to be something, and this could be like this could be, can it be 19? It has to be 3 cells at least. Let me check something. If this is a 1 and this is a 9, yeah, because this is now 19. If we have 8 and 7 and 4, okay, that's the minimum. It needs 3 cells at least for 19. This 19 just means, oh, I mean, in this cell needs to be 19, or these 2 cells need to be 19, or these 3 cells need to be 19. And one of these is a 0. And we don't know which one. Technically, they all can be 0. Or one of them, or even 2 of them, because we get to decide which 0 to use. If this was a 0, this would be a 9. And 0 means they all have to be next to each other. This can be neither a 1 or a 9. Let's say 9, 1. Okay, okay, let's go, because I don't think we can figure something out here. So what did we say? The minimum, if we have a 1, 9, the minimum in 2 cells is 5. Basically 2 and a 3. So here we have a 2 and a 4. A 2 and a 4 means that it has to be a 1, 2, 9 or 9, 2, 1 sequence, and a 1, 4, 9 or a 9, 4, 1 sequence. And we have 9s here. Is that the one? By the way, if I actually solve this whole thing, I might be cutting the video if it takes me way too long to think about something. I will let in my thoughts if I have some genius thought or something super wrong. I will leave it in. But so, okay, none of this is the start. So what if this is a yeah, well, let's say if this is a 1, 2, 9. This breaks this. Because if this is a 1, we have 3 digits. And even if we take the biggest, 8, 7, 6, that's 21, and we have 24. So it can, so it starts from here. So none of these can be a 1 or a 9. 1, 2, 9. The same with 4. Well, this now is impossible. If this was the 1, sorry, 1, 9, and this is the 4. We have 4 digits here. Now that's possible. Again, if we have 8, 7, 6, that's 21, and then we have a 3 here. That would work. That would actually work. So, so for 24, what's the minimum? 2, that's a 5, 9, 14, 20. Now we cannot have another 4. 14. We need a 10 more. Okay, so the minimum. Sorry, the maximum amount is 2, 4, 5. Because 2, 3, 4, 5. Let's say if this was the 1 and the 9. For 24. 15. Yeah. Yeah, that would work if it was this. Can we get one more? I don't think so. It's like 5. No, so it cannot never be 6 spaces. It's too much. Because if it's like that, and those are the lowest, this needs to be a 4. But we cannot have a 4. And we cannot go lower. So if this is higher, let's say this is not a 6, let's say this is 7. Now we need a 3, but we already have the 3. So if we go higher, this needs to be a 2. We already have a 2. If this is the highest, we need a 1. But okay, no. So this never can be. Okay, so the maximum number of cells is 5. And the minimum number was sorry, 4. So this one is either 4 or 5. And we have a 9 here. So it's 1, 2, 3, either here, or either those 4 cells, and this is the 1, or we have 5 cells. So one of these two is the 1. We don't know which one. Was that helpful? I mean, sure, one of these is the 1. Because for 12, and we already have 1 and 9 here. Ooh. That's actually good. These are never used for the 12. So let's say the maximum, and this as well. So we have only these for the 12. So it cannot be only one space, right? Because that is between 2 and 8. It could be 2 though. Okay, fine. Oh, no, that way. Sorry. This is possible. 2 numbers of 12, so not 6, 6, but let's say 5, 7, 4, 8, or 3, 3, 9 is not possible. So 2 is the minimum. That's a strange freedom, because let's say 1 is here and 9 is there. That also works. So what's the maximum digits? 2, 3, and 4. 2, 3. Well, it's fine. 2, 3, 4. So 3 is the minimum because the no wait, the minimum. What did I calculate? Sorry, it's literally almost 3 o'clock at night, and I'm doing this at night because that's the best time. So the only thing I know is this is neither a 1 or a 9, but we can have 3 or 2. Either it's these two, these two, these two. So one of these is always the border. This one or that, this one or this one. And this was never. One of these could be. So how do I note that down? I mean, I can say one of this is guaranteed a 1 or a 9. And, this cannot be the 9. Interesting. If this is the 1, this has to be the 1. Now, if this is the 1, then it breaks. Oh! None of these can be a 9. And we know one of them has to be a border. If one of them has to be a border, so one of this has to be the 1. And we don't know which one. But we know it's not this one. This is never a 1, because if this is a 1, this cannot be a 1 or a 9. So this is never a 1, which means one of these is the 1. I don't know which one. Which means one of these is the 9. Because it's either this, this with this, this with that, this with, this with this with that, or this with that. Ah, I see now. Because for the 24, the 1 had to be there. So this is the 1. And because of the 4, yeah, now this has to be the 9 and... nope, that's wrong. This has to be the 9. This has to be the 4. Like that. I need to remove the purple. Now the green. Ooh, okay. Okay, that's good. 1 1 1 9 9 9. Now, okay, now we know this one is 4 digits. 2 3 3 4 and 5. That's 14. That's not enough. If we remove the 2 with a 6, that's 18. That's also not enough. So now we need to remove the 3 with 7. 17, 8, 9. Oh, that's 22. So 4, 5, 6, and 7. That's 22. So that's still too low. We need 2 more. So we cannot have this to be a 9, because this cannot be a number. Let's say if this is an 8 and this is 7. That works now. Wait, that's also the muck. It's 8, 7, 6, and 3. 8, 7, 6, and 3. Okay, 6 and 3, 4, 5. Okay, so we have a 7 and 8 guaranteed. Wow. Okay, so 7 and 8 are guaranteed. Then we have a 7, and then we have a 3 or a 6, or a 4 or a 5. But we have 7 and 8 guaranteed here. So 7, 8, 4, 5, 3, and 6. That's not the best notation. But so again, we have a 7 here, which means the 7 is not there. So one of these is the 7. Because this cannot be a 4. This cannot be a 5. No? We have a 4. Wait, if this is not a 4. 7, 8. We could still have 4 and 5, yeah. We'll just 7, 5, 4, and 8, yeah. That's fine. Well, whatever it is, we know that the 2 has to be somewhere up here. 3, 4, 5, 6, and a 2. And we know the 2 is not, it's not a 3 because of this. Actually, I shouldn't have removed the purple for the 2, because we still don't know where the 2 is. But if this is the 9, 9, 2, 1. in theory could work, but then we would have the 9 in one of these two, which in theory can still work. Let me check if there's any other digit that has some restrictions, because for the 12 we got this. And why do I have the feeling we get these in the probably somewhere in the end? Because again, 19, we know nothing much here. I don't like pencil marking that much, but 2, 3, 4, 5, and 6. This is not a 4. I don't know if this helps me. I wanted to note down that this is one digit. Huh. For 8 and I think 13. Sorry about licking my lips. It's freaking it's pretty warm. It's 25 degrees and it's end of October. Sorry. Don't forget to hydrate. Oh, this video is sponsored by water, by the way. Yeah. For the 8 and the 13. I mean for Oh, the 8 has to be a 1 or 2. It cannot be more. Because let's say this is a 1. This is a 9. This has to be an 8, right? Fine. If this is a 9, the minimum is 2 and 3. The thing is, it cannot be more, because if it's 3, it's 2, 3, 4, which is 9. So that's the minimum is too much. So this has to be 1 or 2 squares. 1 or 2 squares. So I don't know how to note them. One of these is the 1. One of these has to be the 1. And the interesting thing is, whichever the... I see. Oh, maybe that's the thing. Wait, no? Yes? No. No, that's not... Well, one of these... Wait, none of these can be 1, can it? Because if this is the 1, this has to be the 3 and this is a 9, which doesn't work. This cannot be a 1. If this is the 1, this is the 3, and this is the 9, which also doesn't work. So none of these can be a 1. This cannot be a 1, this cannot be a 1, and this cannot be a 1. This cannot be a 1. The reverse would work, though. No. Okay, no. This technically could be a 9-1. That would work. Making this the 3. Because 9-1, we still would need a 1 here, but... Well, here. But yeah, these can never... So this would work. I mean, here's the thing. Where... Because we have a 6 here, and... The 6 can only have 1 or 2 spaces. Either it's a single 6, or it's a 2-4. Because the 1 cannot be there. So potentially this could be a 1, with this being a 6. The same thing as this could be a 6 and this could be a 1. Like that. This is, for the top, this is the only way to go, but the 1 can also be here, and then this is a 2-4 combination. So interesting, the 1 is either here or in one of these two. Because it cannot be here. So let me remove everything else. 1 was there. So I would assume 1 could be in any of these two. In this box. I did this freaking 4. Maybe something, because it has been staring in me. It must be something about it, right? 1, 4, 8, 9. So I think I can pencil mark these two. It will be a horrible pencil mark, but again, if this is the 1, we don't know. It might be another 1. If this is the 1, this cannot be an 8 or a 4, 9. So if this is the 1, this will have to be the 9, which means this will be this is 1, 9. This is, what did I say? 2, 6 or 3, 5. Now, if this is the one, if this is the one, give me a second. There's something more that I'm missing. Yeah, if this is the one, this cannot be 8, 4, 9. This will have to be 1 something 4 something 9. If it's not a 1, if it's any other digit, and let's say if this is the one, but those are all the possible digits here. Let's say if this is the one, this is either an 8 because it's 1, 4, 8, 9. That's it, because this cannot be a 9 then. Yeah. This can never be a 9 then. Bad. This is never a 9. So this is guaranteed the 9. That's it. This is guaranteed the 9. So either this is 8, 4, 1, or yeah, one of these is the one guaranteed now. I'll remove the yellow. I don't know. So one of these is the 9. Oops. Good. We knew that already, but now we have this as a... Oh, wait, this is a 9. So we found out for 13 it's either 2 or 1. This is never a 1 now. Yeah, this is never a 1. So either the pencil mark. One of these is a 1. Good to know. Because so either you have 1, 6, 9. There still could be a 1 here for the 2, 4. It could still be a 2, 4 here. Now, for the 2, this is never a 1 or a 9. The 9 is somewhere there. If this is the 9, this will be the 1. If this is the 9, this will be the 1. If this is the 9, this will be... but this also could be a 1 if this is the 9. Yeah, these pencil marks are atrocious, but I just want to see... Ones were not possible here or there and not here. So these are also the only possible ones. What about on the bottom? I think in this column, because this is not a 1, so these are all the possible ones. I mean, we know about this one, but what about if we go backwards? Because it's the same thing. 1 cannot be here. So if we go back, if this is the 1, this is the 9, which doesn't work. If this is the 1, this is the 9. So none of these is a 1. This is a 1. That is a 1. According to my logic, if it's correct. Which means this is now a 9, which makes this the 2. Okay. I should mark everything that's done. This is done. This is done. This is done. I mean, yeah, this is technically done. I'll make it green. I know maybe it's not colorblind friendly. Let's do it, I guess, purple. Because I mean, even if you have issue between blue and purple, it doesn't matter. It means we have some. So these are not 2. Oh, that's a single digit. That's a 2. Oh, good. Wow. Now, this is a 9. If this is a 1, this is a 6. If this was a 1, 6, that's a 2, 4. Oh. Now I have a... Wait, no. So, wait, this cannot be a 1 now, right? Because if this is a 1, how do we make 6 here? With 2, 4... Oh, yeah, 2... We cannot have 2... Oh, we have 2 actually there. So, this cannot be a 1 because we don't have 2, 4. And this cannot be a 1 because we already have a 1. So, oh, wow, okay, I get that. That's a 1, 6 now. We remove the 1s here. Remove the 6s from there. Oh, that's not a 1 now. Which means this is a 1. Which means this is an 8. Because 12, yeah. This is not... Okay, so the 8 is here. Down here. So that's done. We have... Wow, we have the 12 done. That's it. This is a... this is a 1 now. Because it cannot be here. It is here. But if it's the lowest, what was it? 258? 252? No, we don't have a 2 anymore. 3, 4, 5. Ooh, 3, 4, 6. Because no, this is a 1 now. What do we have? No, we don't have 3, 4, and 5 is 12. Oh, it has to be 3, 4, 6. This is not a 6 because of that 6 then. Oh, we have that one done. Sorry. No, wrong. 6 is done now. Ooh, we are so close because this could be a 3. And we have 3, 9 here. But if this was the 9 and 3 was 4. No, that's a triplet. We have 3, 4, 6. So 3, 4, and 6 can never be here. So if this is a 9, look, this will break. If we have 9, 3, 3, this now breaks because this is a 4 and then we have 2 6s. Ah, very clever. So this is indeed the 3 with a 9, which means this is also blue now, which makes this a guaranteed 4 with a 6. This is not a 3, 5. No, 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 don't delete wrong digits, please. Okay, so we have that, right? That's 13. It's done. So this is 5, 7, and 8. Oh, that's a 0. That is a real 0. I mean, but it says if there are multiple zeros. Well, here's the thing. If this is a 0, this has to be 19 if those are not zeros. This is a 0, so now this has to be 19 if those are not zeros. If this is a 0, this can still be anything. And if this is a 0, this and this together could be 19. I see. So we don't know yet. Also, this is purple because we have the 1 and 9. And this is also purple because we have the 1 and 9. We just don't have the digits yet. Ooh, 8. This is a 2, which means this is a 9 now because now we have 8. Because the minimum with 3 is 9. This is not a 2 based on the pencil marks. Actually, 9 has to be somewhere there. Yeah, I probably should check the 16 then. Well, if 9 is here, this is a 0 again. What was I going to do? We have that one. Oh, interesting. Well, how many 1? 1, 2, 3, 4, 5, 6, 7. We need 2 more 1s, which are here or here. On X-Wing. No. Oh, right. It cannot be there. Because 9 and 1. So 1 is guaranteed here. Which makes the 1 here. I want to check the 16 so that I know if... We have a 2 here, but it doesn't matter. Oh, well, there is a 2 there. No, I just want to calculate something. So if we had... And don't mind this 2 now. Even it's 2, 3, 4, and 5. The minimum. 14. This is possible. Because imagine if we had 7, 4. Like that. 10, 14, 16, right? That would work. This is interesting. The minimum is if we have a 3 and a 4. 15 is the minimum. It's the maximum. Huh. 8, 2, 6. Wow. So we can actually get 19 if this is an 8 and a 3. Or a 3 and an... Oh, we have a 3 here. Yeah, 3 and 8. Because that's 10, 16, 19. That is this. And the minimum... 2, 3, 4... Wait, oh. Oh, well, so we cannot have 3 there because of this. And we cannot have 4 because of this. So 3, 4... Yeah, that would be 16. The minimum is 16. And we would need a 3, right? Is there another minimum? If this is a 4? We need a 2. No, this is the 19. This is the 19 because if this was a 3 and 5, this is 16, so we need a 3, but we already have a 3 here, so none of these can be 3, or 1 plus 2, because 1 is not valid. Also, the 2 or 1, that's it. Those are all zeros. Those are all zeros, and this is the 19. So, can we have 3 and 8? Oh. 3 and 8. 4 and 7. 4 and 7. 5 and 6. Oh, we have a... Okay, that's it. That's 19. We have that. So those are all zeros, which means this has to be a 9. Which this is also 0, and this cannot be a 9. So this is a 9. Oh. Oh, okay. This cannot be a full 7. So these are 2 digits. 3 and 4 and 2 and 5. 3 and 4 and 2 and 5. For the 7. We have the zeros done. We have the 19 done. Oh, basically we have the 16 done. We have everything now. And if we take the sum of this is also true. So this looks correct. So we should start filling in digits. Yeah, easier said than done. Yeah, for example, here for the 16, what are the possible digits? Like all the purple ones, even though, yeah, let's fill in all the purple ones. So here for the 14 with 3 digits, the minimum is 9. Ah, well, let's say if we have a 3, we have 11 to go. If we have 4, we have 10 to go. If it's 3, we have 11, right? And 11 is 5 and 6. So if this is a 3, this has to be a 5, 6. Or, right, this is a 3, right? Yeah, if it's 3, it's a 5, 6. If it's 3, it could also be a 4, 7. No, it cannot be 4, 7. Good to know, because of the 7. 4, we need 10. So we cannot have double 5, so we have 4 and 6. And 3 and 7, but we already have... So, if it's a 3, we have 5 and 6. If it's a 4, we have 4 and 6. We don't know what it is, but we know there is a 6 here, guaranteed, in this box. So there's never a 6 there. This is never a 6. That doesn't really help here that much. Let's check this for this 16 here with 3. So the minimum... what are the possible digits? Because technically we can have 2. No. If this is a 2, this has to be double 7. No. Or 6, 8. And we already have a... we already have a 6 and 8, so that's not a 2 here. This is actually limited. Interesting. So we don't have a 2 here to work with. So we have to work with 3, 4, 5, 6, and 7, because we cannot have a 2 here, and we cannot have an 8 here. Now, yes, there is some 3, 7, 6. Oh no. Okay, that does work. I would have had a triplet here, and then I could. Oh, wow, we don't have many 4s, do we? No. We don't have that many 4s. What about 5s? I'm just checking something real quick. Okay. If that helps. 7 is one of these here, which means one of these is a 7. Okay, 8 is there or there. It's either 3, 5, 6 or 4. Yeah, 4 and then 4, 6. Of course. Because I was about to say, if one of these is a 6, we need 12. How do we make 12 with 3? We need 7. No. Sorry, it's not 12, it's 8. If we have a 6, it's 8. How do we make 8? Either 3, 5 or 4, 4. How can we have double the 4? I'm so sorry I didn't see that. That's just this is a 3, and this is a 5, 6 pair. I am just slow this evening or night. Yeah. That's more like it, because now that's a 5, 6 with a 3, which is correct. This is not a 3 now. Apparently because of this 3, and because of this 3, this is also not a 3. Oh! Yes. Because now, this is never a 6. Because now we cannot do a 10. Because the only way this was a 6 was this was a 7, 3. So this is never a 6. Which means we have a 4, 5, 7 pair. Triplet. Yeah, 4, 5, 7 triplet. No 4s and 5s here. Truncating stuff. I'm Oh, and now we have this. This is how much? 8. This is an 8 now. Because if this was yeah, this is an 8. We are done with this. This is not an 8. This didn't really do much. But now we have this one as well. So wow. We actually got all these first before these here. And also just purple, because we have the numbers, the digits. This 7 here, this is never a 2, this is a 3, 4 pair now. The 2 is never here. This is a 3, 4. Or the 7, which means 3 and 4, which means these are not 3 and 4. Three, 5, 3, 5, 6, 5, 6. We have a triplet as well, so this is a 4. Removing the 4s from here. Oh, 4 is here. Oh, this is a 4, 8 pair then. So we have 24, and we have 4 and 8, which is 12, so we need 12 here, which is the 5, 7. So this is not 3, right? Yeah, this is not 3, this is not 6, so this is the 5, 7 with the 4, 8. 5, 7. Oh, this is a 3 now. Oh, and it's not 5, so this is a 6, 5. We got this one. Brilliant. Next. 4, 8. Okay, we have 5, 7, so this is not a 5. Okay, this is a 3. Which means this is a 2, 6 pair. Two, 6, 5, 7, 4, 8. Okay, I got this one now. Filling up the boxes. What's left here? 1, 2, 3, 4, 5. 5 and 7. What is left here? We have 1, we need a 2, 3, 4, 5, 6, and 6. Okay. Yeah, do we have a 3? Yep, we have a 3 here. That sounds fine. No, it doesn't sound fine. We have a 3, 4 here, which means this is not a 3. And we have a 3, 4 here, which is not a 4. Oh, I see. That's why that is... Oh, and we have 5, 6 here, so this is not a 6. 6, 3. I'm just going slowly. I cannot scan this so fast to know how to solve it, but we have a 3-4. So we need a 2-7 here, right? We have a 2-7 pair. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which means this is not a 2. Oh, it says we have a 2 here. Good. Now we have the 7 gone here, which means this is the 7. We remove this 7. Oh, that resolves here. We have a 5. Oh, that's... Oh, did I do something wrong? I think I did something wrong. Sorry. What did I do wrong? Okay, I couldn't really figure out where I broke it, but I think it's one of the rules that I misinterpreted or forgot. Even though this is a 19 and this has to be a 0 because we found out this is a 19, these two do not have to be zeros because they can be anything, because the sandwich clue just tells you from the smallest to the highest digit, which is true. This is 19 here. But then everything outside the smallest, so this can be anything. So I assumed everything has to be 0. And yes, if I think that's the one. If everything is 0 here, yes, we can choose any 0 and this is always true, but these don't have to be 0 because this is the only digit that has to be 0. So we don't know what these are. So I'm assuming this is the 9 here. Probably broke everything because one of these has to be the 9. And 9 here broke it, so probably the 9 is here, but I cannot prove it. I want to start filling up stuff, because let's say I don't know the knowledge, but this must be it, because I went with Control Z through everything, and it seemed, because the 457 broke here. I should have seen that a longer time ago if I pencil mark these. I can still... I think I can now actually go with the 14, the one that I haven't seen from everywhere, because see, this we still have here. Also, yeah, we have that. This is our thing to figure out the 19. So what did I say? If this is a 4, this had to be a 10. So 4, 6. Which if this is a 4, this cannot be a 4, 6 because we have 2 4s, right? Or it has to be 3, 7, and we already have a 7, or 2 8, right? So it could be 2 8, because again I don't know. So if this is a 2, a 3, this can be a 2 8. Sorry, not 3. If it's a 4, it can be a 2 8. Because there's nothing that prevents... I think something here prevented this being 2 8, that's why, but no, it could be 2 8. If this is a 3, 11, 5, 6, 4, 7, or 3, 8. No, it cannot be 3, 8. What did I do? 5, 6, 4, 7. It cannot be 3, 8 because we already have 3 here. So that's the possibilities. With 3, it's 5, 6, or if it's 4, it's 2, 8. Okay, that seems plausible. Make this purple. So 9 is still in one of these two. Oh, okay, yeah, makes sense. So yeah, if either this is a 7 or too many. So if this is either 7 or those are 2, 5 and 3, 4. Oops, that's a lot. No, I'm not pencil marking that. This is a 9. What's the next step here? Okay, we have that as a purple because we have the digits. Yeah, we can check what this 1, 2, 3, 4, 5, 7, and 8. And we have a... yeah, so we have the 8 here. Okay, 5, 7, 5, 7, 8, 7, 8. Wow, it makes sense, but one of these is an 8, one of these is an 8. We need to work with the yellow digits now. No matter what, where the 9 is, this is either a 7 or a 2, 5, 3, or 4. Oh. And then we also know this one, because if this is a 9, we know it's a 9. If it's not a 9 and this is a 9, then we have 2, 5. Oh, sorry, 2, 5, 3, 4, 9. And this can be either 9 or anything. Oh, we know the 0. I need to go with a 16. Oh, right. Actually, the pencil mark that I had was correct. It's just I had to extend it. 4, this was 12, which means 6, 6 does not work. So 5, 7. And 4, 8. And we cannot have 4, 8. If this was 5, we had 11, which means we need 5 and 6. We have 6 now, 5 and 6. 4 and 7. So we could have a 4. Yes. And remember we said, I would have said, oh, we have a triplet. Nice. But now this could technically be a 6 as well. I mean, it's the same pencil mark. If it's 6, it's 10. So 5 and 9, 4 and 6, 3 and 7. Yeah, and this cannot be a 3. So this was the one that says, oh, 3, 7, 6 is still a possibility, right? And that's why we didn't have a triplet. But now, now. What about if this was a 9? Oh, remember, we couldn't have had a 2 here. If we had 2, 3, I think 4 and 5 is anywhere, so let's say 4 and 5. That's 14, so we have 2 degrees of freedom. So we do need a 2, if that was the case. 3, 4, and 5 is not 14, that's 9. I mean, we cannot replace the 3 with a 6, because 6, 4, and 5 is 15, and 2 is 17, so that's too much. So we cannot replace the 3. We need a 3. 2, 3. So we would need a 2 and a 3. Because 2 and a 3 is 5, so we need 11. And now we could either have 4 and 7 or 5 and 6. And this is possible because these cannot be 6, but one of these could be a 6. Okay, see? So again, if this is a 9, this is always a 9. This is a 9. If this is not a 9 and this is the 9, this can be a 2, which we need a 2. There needs to, it cannot be a 3, because this will be the 3. 4, 5, 6, and oh god, that's amazing. That's pencil mark. But unfortunately, that's it, because we have a no. No. That's so I said we need a 2 here, and because the 2 can be never okay, this could be a 2. I see. This is an evil 16. I think we can truncate this a bit, because if this is the 9, this is always the 3. There's no other possibility for these two. So this is always a 3. One of these is the 2. So let's say this could be the 2 with the 3, and then we have, let's say, 5 and 7. That's fine. 4. This will be 2, 3, and 4 with 7. If this is a 5, this is a 2, 3, 5. This cannot be a 5. So this can never be the 2 and a 5. If this is 1, 9, this cannot be a 2, 5, because if this is 2, 5, it removes the 2, 5 here. Then we have 6, 8 here. 6 and 8 is 14 already, and we need another digit. So this is never 2 and 5. Oh, okay, yeah. Sorry, I pressed 8 instead of 5 because this is never an 8. I mean, for a 7. No, I wanted the 5 there. Okay, now that's correct. 2, 5, and 3, 4. Yeah, now it's sorry that I just clicked pressed the 8 instead of the 5. But now this is still valid. This cannot be a 2, 5 because this breaks. So this is not a 2, 5. Now that's good. So either this is 3, 4 with a 9 here, basically 3, 4, 9, or 7, 9. I think I can truncate one number here. I don't think can the 5 be ever down here? 8 and 5. It's 13. So I need 11 here. Oh, I don't have a 4, so this can never be 11, no matter what I do. That's I never spotted. What else do I know? So one of these is a 7. One of these is now actually a 7 that I've never seen. Wait, what? When did I delete these? I sadly I cannot look this up, so I have to recalculate this because I don't know when I removed this. I think I got this now. Yeah, this cannot be 1, 3, or 8. I never checked what can these be because these are already very limited. They cannot be 1, 2. Right? 1, 2, 3. 1, 2, 3, 4. Oh, this is a 4 here, so this is not a 4. Everything can be a 5 because we still don't have 5s. 6 cannot be 7. Do I have 8s? Ooh, okay. 8. Those are the possible ones. Ah. Well, that's the break-in then. Exactly this, well, break-in. This box, where does the 3 go? Yeah, it's not here and it's not here, so this is always a 3. Oh, this is not a 3 anymore. Because I have a freaking 3, so I should check if I can do anything. Yeah, I can do something with it. Yes, this just forget about this. Okay, this is not 4. Ooh, now the 4 is here. Good, but oh, so for the okay, 4 is not here. For the 14, we have a 4. So we need a 10, which is 2, 8. It's not 5, 6. Wait, it's not 5, 6 here. It wasn't 5, 6 here. Oh, no. It's actually not 5, 6 here. So it's 2, 8. Does that help? This is not an 8. Oh, that helps. This is not an 8, which means this is always the 8. If this is 8 and 3, it needs to be 13. So it needs to be 6 and 7. If this is 8 and 6, which is 14, this needs to be 7 and 3. So this is never a 5 now. Because if this is a 5, 8 and 5 is 13. So we need 9. Oh, wait, it can be 5. No, it cannot be. If this is a 5, we need 3 and 6, but one of these has to be 7. Okay, yeah, it's never a 5. So this is the 7. Because yeah, this is 7, 6 or 7, 3. Yes. So this is never a 5 here. And this is also not the 7 here. Because this is the 7 now. Which means this removes the 7 from here. Like that. So we have 3, 6. So we remove the 3s and the 6s. Oh, right. Because of this 3 now. Because I was about to say, we have a triplet now. What? Because of this, but no, I could have seen this a long time ago. So this is always the 3 now. Right. Which makes this one the 3. Which makes this a 5, a 6. This one now is the 6. This is now a, well, yeah, it's a naked single. It's a 4. Like that. Oh, yeah, and that okay, that's 7, 8. That is how it fixes this down here. Because if this is a 9, now we cannot make a 7 here anymore. With 2, 3, and 3. So now, okay, I see. Yeah, that's how we do it. So that one makes it so that I know now this is a couple of digits, like the 4. It's not a 5. This is not a 2. So what do we? So this one now is blue. This one is almost done. We have this one now. Okay, this is 5 7 8 7 8, so this is 5 7 8. This is how much was it? 10 12 7. This is if I'm wrong again. 2 3 4 5. Yeah, this is a 1 6. It's a 6 7 pair. So we need a 2 3 and 5 missing. And we have a 2 8 here, so this is not a 2 5 6 7 8 9. Okay, we have the 7 here. Okay, one of these is 4, one of these is 6. I have that one. Now if I'm not wrong, and if I didn't blunder again somewhere, this should work out soon ish. Oh, we know one of these is a 2. 3. It cannot be this one. 6. 4 and 7. A 3 5. Wait, it's only a 3 5, and we already have a 5. 5. Yeah, we have a 5 here, so this should be a 3. This is a strange pencil mark that I have here. I don't know from where it is. So what are we missing here? We're missing a 2, 7, 8, 9. Oh, this is a naked single. Why? Oh, we have 7 and 8 already. Here, 7 and 8. So this is a 2. Okay, I see. Which means this is a 3, 2. It must be this then. What I figured out is one of these has to be a 2, which makes this not a 2, which I see. No matter what, we need a 2, which means this is never the 2, which makes this one the 2. If that even helped, I don't know, but 4, 5, 6, a lot, wow. Not 7, this one, 8 and 9. Okay, this is 5 and 6. So there's a 3, so this is a 3 here. I think everything can be a 4. 5, 6, 7 and 8. 4, 5, 6, 7 and 8. Oh, we have 7 here. So if this was a 3, it would be 32, and we have a 32, so it's not a 3. If it's a 4, it's a 31. We don't have a 31. Ugh. So it's a 5, it's a 30. We don't have any of them, but it removed the 3 from... Wait, it removed the 3 from here. That's a single digit now. Also, we have 2 8s, so I could have removed these 8s here as well, but it removed the 3, which is very important because that is now a 3. Oops. 2 6, which makes this one the 3. I think I can remove one of these numbers. Which one was it? I think I can remove the 5 here. 4, 5, 7. Yeah, I can remove the 5 from here. I'm just missing something somewhere. But where? Okay, guys, I'm so sorry. Again, I'm very bad at scanning, so I just scanned, and yeah, in this row, the only way the 2 can be is this one. Sorry if this was painfully obvious. Do remember my eyes, I have over now 11 diopters and everything is wrong with them anyway, so yeah, this is a 2. Like, it's a naked single here, which made this a 6. So how does that progress? We remove the 6s from here. See how I need to start thinking how to scan? Because yeah, see the 6, so now this is a 7, which should remove 7s here. Okay. This can now never be a 4 because there's no more 7. Because let's say 2 and 3 is 5, and 4 is 9, and now we need 7. So this now is always a 5. I think that's the one. Right. Now we remove the 5s from here. Oh, well, I mean, this has a lot of stuff now going on and resolving. Basically all these. And I'm going now. Oh, wrong. That's 8, 4, 8, 7. Oh, I made it. Wait, we are not done yet. No, 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 no. No, 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 no. We are not done yet because I want to do this one as well. So that's 35, 30, 31. And now this is it 31? Yeah, 31. And this is 10, 17, 21. Ugh. Now, now, now it's solved. Oh, less than 3 hours. What's the time? 3:50. So 10 minutes to 4 in the night. Yeah, I should really not do Sudokus that late at night, but I really enjoyed this one. This is your additional reward. Xenonetics. This is a 4-star one. And aside from this one blunder where somehow I assumed everything has to be 0 after that, I got it. Wow. So let's actually finish this the proper way. Like that. Everything is now marked. Hope you enjoyed. And yeah, this was a fun, long night, evening, whatever. So everyone have a good day, night, or just bye-bye.